So thanks everyone. Tim Purves here from Icon Water. I'm going to give you a slight change of pace because I'm going to focus on urban water supply, but it's like everything else, it's all related to the Murrumbidgee River because all of our water comes from one place, which is the Murrumbidgee River catchment. So I'm going to go through a few things today. We're going to start with the water balance along the river, which just gives a picture of where water is coming from and where it's going. And I'm going to do that in average conditions and in dry conditions. I'm going to talk briefly about the two main challenges that we're facing for urban water supply. And I'm going to go into detail on one of those challenges, which is the population and demand growth. And then I'm going to talk about what the implications of that are, both for the river and also for Canberra and Queanbeyan as an urban supply area. So starting with the water balance in average conditions, and this is really driven by the last 4 years, which have been quite wet. They have a big impact on the average flows. So I'll just go through the river from the headwaters all the way down. So if you start at Tantangara Dam, I haven't got the inflows and outflows shown here. I've actually got the river gauges upstream and downstream of the dam. But you can see that there's 150 gigalitres a year going into Tantangara and 100 coming out. The inflows are probably a bit bigger than that because not all of the catchment would be covered by the gauging station. There's more inflows coming in by the time we get to the ACT. And then the ACT itself is really quite a productive area. There's a lot of runoff coming in from within the ACT. I'm counting Molonglo and Queanbeyan rivers as part of the ACT here, which is probably personal bias because we use them for water supply. Our urban water take is around about 50 gigalitres a year, and that's out of a total of 900 gigalitres that is going down the river downstream of the ACT. So not a major component of the water on average. And the other thing that's really important to be aware of is that we return about 2/3 of the water through our wastewater treatment plant discharges. Whether that's a good thing for the river or not is a matter of discussion, but that's what happens here. And it doesn't happen, of course, with other irrigation and other diversions, including Tantangara. But, of course, what we really care about as water supply planners is the dry conditions. And this next slide shows what goes on in droughts. So the red figures here are the average conditions from the 2018-19 period, and you can see all the numbers are significantly lower than on the previous slide. Less so in the mountainous areas. So the inflows to Tantangara have gone down, but not as much as everywhere else. When you get outside the mountainous areas, you can see the flows are almost dropping off to zero. I haven't accounted for irrigation in here, so that's probably playing a little bit of a role in these numbers as well. ACT contribution has dropped off to about 100 gigalitres a year, and remember that number because we'll compare it to demand later on. And what's also interesting is that when you look at the demand, it goes up, of course. The flows are going down, but because it's drier, the demand for water is increasing a bit. So our urban consumption's gone up, our sewer returns have gone down, and it looks like Tantangara is also diverting more water too, which is not surprising given that there'd be massive demands for water across this period. So the 2018-19 period was a bit of a wake-up call for us, given that our dams got down below half full, and it happened very quickly too. By a lot of measures, it's the most severe drought on record in Canberra. If you look at total flow over 2 or 3 years, it certainly is in that category. And what was interesting about it for me was that while the rainfall was certainly down, it wasn't worst rainfall we've ever seen, whereas in inflow terms or in river flow terms, it was worst we've ever seen. So at first I thought that might have been something to do with climate change, but the more I look into it, the more I think it's got a lot to do with the cumulative rainfall deficit over a number of years. So we didn't just have a short, sharp drought in 2018-19. That was the culmination of it, but we had low rainfall in 2017 and 16 as well, and when you put it all together, that resulted in really low inflows in that 18-19 period. So we went through our review process. We have revised all our estimates of future inflows to align with the conditions that we saw here, or to align with that response between rainfall and runoff that we saw here. And the result of that assessment is that our water security is still pretty good. For the next 10 to 15 years, our security is fine, but at around about that point, we're going to need to find additional sources of supply or reduce our demand. Prior to that assessment, we were thinking that we had a few more decades, so that is a major shift in our planning. And of course, the two things that are causing concern are really population growth. That's kind of the focus of this presentation. We're looking at population could double over the next 50 years from 500,000 to 1 million. And the other thing is climate change. And this isn't a presentation about climate change, but it's very clear that temperatures have already increased and are going to increase further. When we go into a drought again in the future, which we're certain to do at some point, we can expect temperature to be higher again. The impact on rainfall is really hard to quantify. Anybody who tells you exactly what's going to happen to rainfall in Canberra, I wouldn't believe them, because it's a complex system and very hard to predict. But I just want to echo Bradley's comment about rainfall shifting out of the cooler months and into summer. And we're certainly seeing evidence of that. And from a water security planning position, that's bad news, because summer rainfall doesn't result in as much runoff as it does in the rest of the year. So focusing on population growth, we currently supply just over 500,000 people. That's in both Canberra and Queanbeyan. And we've seen relatively rapid growth over the past 20 years. Our population has doubled over the last 40 years. Future estimates of population are always going to be uncertain, but we can go and get population projections from a variety of sources. We've got two here. The dotted line is the main one we use for planning, which is the ACT government projection, and the range is the Australian Bureau of Statistics low and high estimates of future population growth. They've been combined with population growth estimates for Queanbeyan as well to get the total figures shown here. And what that's telling us in simple terms is that we could see population doubling again in the next 50 years. None of these numbers include an allowance for growth outside of Canberra and Queanbeyan, but there are other regions that are going to need to be supplied from the Murrumbidgee Basin as well. Yes, Murrumbateman, possibly Bungendore, for example. There's a chance that they could be connected up to our water supply system, but even if they're not, they're going to take water out of the river. You do have to treat these projections with a bit of a grain of salt. So if you go back to the 1960s, you could see population growth was projected to be well over 1 million people by now, and that hasn't eventuated. Canberra was growing at about 10% at the time, and the projections just assumed that that would go on forever. And about 20 years ago, when I started, I was a graduate engineer and I got the job of doing future planning for our water supply back then around population. I rang up the ACT demographer and I asked if we could get high growth numbers because we wanted to plan for high growth. And he said, oh no, you don't need to do that. High growth is never going to occur. I can give you some low growth numbers. And I thought, okay, well, how about you give us some high growth numbers as well? And he did. And what we planned for was 500,000 people by 2023 from the high growth, which is almost exactly what happened. So point of the story is these things are hard to predict, and I can imagine futures that are outside the range of what is up here too. Now we get into the exciting stuff from my point of view, which is water consumption. And this next chart shows how consumption's changed over quite a long term. So we're going back to the 1960s here. The two series, the blue series shows our total consumption, Canberra and Queanbeyan, and the orange is the per capita usage. And what's really interesting to me about this chart is how much the per capita usage has changed over time. You can see there's two really big drops. The first one occurs in the late 80s, early 90s. That's probably as a result of the introduction of volumetric water charging in Canberra. And then there's another gradual one that is sustained after the millennium drought. So you get this really big decline in water usage all the way through the 2000s, really. The net result of all of that is that you can go through whatever statistics you like, but what it really means is that our consumption now is less than what it was 40 years ago in total, even though our population has roughly doubled in that period. What we want to do after that is project where consumption is going to go in the future. So let's start with the per capita line, which is the orange one on this graph, and try and estimate where that's going to go. We assume that per capita is going to continue to decline. We assume that for a few reasons. Technology is going to continue to improve. Water efficient appliances and fittings are going to continue to be installed in houses, and that's going to gradually drive demand down. But probably more importantly than that, we also think demography is going to change. The housing density is going to move towards a higher density, more units, more townhouses. That's likely to result in people using less water per person than they are now. It's possible that we'll be able to do better than this. If we really focus our attentions on water conservation, we might be able to drive per capita usage down lower than is shown here. For example, in places like Melbourne, Brisbane, Gold Coast, they already have lower consumption than us. But of course, they also have different housing densities than us and different climates. So we should also acknowledge that a lot of the low-hanging fruit has already been taken. We've already made significant improvements in our water consumption through the millennium drought and earlier, and it's going to be hard to make further improvements as we go on. So, if we have per capita usage projected out into the future and we have population, we can project what our total usage is going to be. And what we're seeing here is consumption going up from 50 gigalitres per year now to 90 gigalitres a year in 50 years' time. So population roughly doubling, consumption not quite doubling, but still increasing in a big way. And if you remember back to those earlier slides I showed with the water balance, 90 gigalitres a year is getting to be quite a scary number, because in drought periods, the whole of the ACT's runoff is only just over 100 gigalitres a year. And we can't and shouldn't catch every last drop of water. So we've got to find a place of getting some additional supply. And this is challenging, given that at the moment, all of our water comes from surface water, all of our water comes out of the Murrumbidgee catchment. The other point that I make several times through this presentation is that our wastewater returns tend to operate the same way all the way through, so that 2/3 ratio can be expected to continue into the future. We're going to be taking more water out of the system, but we're also going to be putting more water back in the form of wastewater returns. Now, you may not realise it because I've hidden it really well up to this point, but I'm actually secretly a modelling nerd, and I really want to have one super nerdy modelling slide here that I can talk through. So this is about how we actually do these projections of per capita water usage in more detail. And we start by dividing water usage up into lots of different categories. So we've got the four main ones for us are residential, non-residential, non-revenue, things like leakage, firefighting, metre underreads, and we've got Queanbeyan as a separate category. Sorry to Queanbeyan, I know you have your own residential, non-residential and non-revenue, but because you only make up 8% of our demand and we don't have your billing data, we just lump you into a single category. And once we've got these categories, we can go through our customer meter data, and we can do even better than this, because our billing data is separated up into high density residential and low density detached residential, and we've got several different categories of non-residential as well, some of which are dominated by irrigation and some of them aren't. So we separate out all of those, and then we keep separating because we want to go down to the individual end users. This we have to take a bit of a guess on because we don't actually have data on how much water people are using in their toilets, how much their showers, how much their kitchens, how much their laundries, and how much in irrigation. But we take an estimate of all of those things. And the reason we do that is because we can then project what's going to happen to all of those things as water efficient appliances get rolled out across the whole of Canberra and everybody adopts them. And any type of water usage behaviour can be modelled in the future. So we project out all of those individual end users, add them all back together, and we can also project our customers because we've got population projections going forward. So we project numbers of customers in each category, and that gives us the plot that you can see there where all of the different categories add up to that overall demand projection. The most interesting thing I find about this graph is the blue series, which is the detached residential. It's not really increasing much. Couple of reasons for that. One is because a lot of the growth is actually in the high density residential, in flats and units. The other reason, of course, is that the water usage per person is declining in the residential, so that is helping to offset the growth a bit there. So, what are the implications of all of this? The extra 40 gigalitres of water has to come from somewhere, and the most obvious place is the Murrumbidgee River catchment. Upstream of the ACT, obviously there's no impact because we're taking the water out here. With one possible exception, and that exception is if we're able to access water from Tantangara. And I should stress to everyone in the room that this is just an idea rather than something that we're actively pursuing at the moment. But in the past, we did have an agreement with Snowy Hydro and with New South Wales that allowed us to call from water from Tantangara if we chose to do so, which we never actually did. If we were to have such an arrangement in place, that might actually increase the flows in the Murrumbidgee upstream of the ACT. It wouldn't necessarily do anything downstream of the ACT, but there's potential for synergy between urban water supply and the environment there, because we would likely be calling for the water at times when the natural flows are quite low. Downstream of the ACT, if we're taking more water, it's pretty obviously going to result in reduced flows because there's only one place it can come from, unless of course we are able to get water from outside of the basin. There aren't a lot of obvious candidates for that, but I guess we could theoretically find a river that's outside the Murrumbidgee Basin and divert it here. The other possibility is desalination, which I really think is a bit of a long shot, but it is technically feasible. It's been done in places where it's harder to do than Canberra. 2/3 of our take will still be returned through our wastewater discharge, unless of course we reuse our wastewater, in which case that will be affected. Doesn't mean it's a bad thing to do, but wherever we take our water from, it's going to have an impact on the river. And my last point on this slide is that we have requirements through the Murray-Darling Basin Plan around how much water we can use. We're actually likely to comply with those because it's a net abstraction that is our requirement. So it's our total take less our wastewater returns. And that is likely to be met throughout the 50-year period. Where we might actually have a problem is the physical water rather than the paper water requirements. So last slide, I promise. So what does this mean for urban water supply in Canberra and Queanbeyan? there's obviously going to be a whole range of minor projects around building pipes, pumps, and maybe treatment plants as well. But from a bulk water perspective, our existing system performs pretty well. We don't need to do anything for 10 to 15 years. After that, we're going to need to either reduce demand or increase supply, and in all likelihood, we're going to need to do both. We've commenced customer and community engagement about what our water future looks like. We've started that this year, and that's going to run for another couple of years or so. And we also need to engage with a whole range of other stakeholders, including the people in this room and a number of government agencies too. We need to look at every type of possible future water supply that you can think of, as well as reducing demand management. So we don't want to rule out any options at this stage. We want to consider traditional surface water supply options as well as more innovative options like recycling. And it's important to recognise that wherever we're taking the water from, it's coming out of the river. So I'm not arguing that we shouldn't do rainwater reuse, stormwater reuse or wastewater reuse. They all have their places if they provide benefits, but we should be mindful that they take water out of the river just like any other type of water use. And climate independent options, manufactured water obviously has a lot of value. As climate is becoming more uncertain, it gives us a reliable source of water that we'll be able to access even if we go into really severe droughts. Our difficulty with that is that all the other Australian capital cities are in the same position as us, but they all have desalination plants. And while that is not impossible for Canberra, it's certainly a difficult solution. So we're going to look at some other solutions that are not being adopted elsewhere. Thank you.